Hello everybody, my name is Billy, and in this video I'm going to be showing you a dependency injection tutorial. So the approach today is going to be a less theoretical and a more practical. So what I'm going to do is I'm going to build a console app that handles order management, and it's going to do payment, shipping, and product stock checking. And then afterwards I'm going to refactor this code with dependency injection in mind. Some of the benefits right away you'll see with using dependency injection is that your code is very testable now. And some of the more long-term benefits is that your code will be more reusable and it will be more readable to whoever is consuming it because all the apparent dependencies will be right up front. But some of the cons of it is that there is a bit of overhead when you first start with dependency injection because most of it seems kind of trivial and doesn't make sense until you actually kind of build your app out to a lot more larger scale. So let's get started by creating our console app. I'm going to file, new project. I'm going to go to console. I'm just going to call this dependency injection. I guess just tutorial. Let's just call it dependency injection, just to kind of keep it simple. Okay, so now you have your console app. We're going to create first a product that we want to be able to order with. So I'm going to go here. I'm going to add a new class. And my product is just going to be a very simple enum, just so I can have like something quick. And I'm going to just maybe make one or two products. So let's make, what do I have here? I have a keyboard I'm typing on. That would be 0. I have a mouse. That will be 1. I have a mic. That would be 2. And I have a speaker, and that would be 3. Okay, so this is my product list. Now let's go make our order manager. Add new. Let's call this order manager. And our order manager is just going to be public void, and it's just going to be you submit your order, and you're going to submit a product, and you're going to provide some payment methods. So you're going to have a string credit card. I guess credit card number, string, expiry date. And let's just leave out CVV since this isn't going to be a real system anyways. Okay, we'll leave this for now, and let's just go to our main to kind of just take in the product and just send that product to the order manager. So let's, I'm just going to remove this first, and let's go create a while loop. And this while loop is going to determine if we put in a exit command. So let's create our product, and let's start off with empty string. And we're going to make sure that whatever we pass into our product is not equal to exit. And then let's product read line, console read line. So we're going to read in our product. So let's tell them what product they can actually put in. Let's go here, enter a product, and then let's copy. I'm going to do an @ symbol so that we can kind of have multi-line. And let's copy our products from here. Okay, perfect. And then once we get the product, let's if enum dot try parse, let's parse our product. We're going to pass in product, and we're going to get out the product enum. Okay, and we're going to say this product enum. And if it parses it properly, then we can call our order manager. So order manager equals new order manager. Okay, and then let's just cover the else statement for now. And if it doesn't fit, then we go console write invalid order or invalid product, and then it will loop through. So at the end of it, let's put in a line break so it kind of looks all nice. New line. And here we go, well, you know, let's move this outside so we don't have to create a new instance of this every single time. So let's go order manager dot submit, and we're going to submit in a product. And now we're going to need to ask our customers if they put in a valid product. We're going to need to ask them for their credit card information. So let's ask them for that now. I go here. I'm just going to do the same thing. Please enter a valid payment method. Let's do a kind of a CSV separated so we can kind of save time. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 16 characters, and we're going to say the expiry is month, year, like this. Okay, and then we're going to say var payment method equals console dot read line. So we're going to read in our payment method, and now let's just do a check to make sure that they actually entered something. So let's go if string dot is null or empty payment method. Let's also check to see that they entered in, I guess, 2 things. So, or we go payment method dot split. And since we asked them to kind of format it in this way, we're going to take the CSV here, and we're going to say the length of it has to be 2 because we expect kind of a 2-part thing. And if not, then we're going to throw, yeah, let's throw an exception instead of console right out so we don't have to always return. So let's wrap this over here in a try catch. So try. Okay, and then we're going to take this and we're going to dot message. And here, where it fails, we're going to say throw new exception. And we're going to say, and also not equal to 2, invalid payment method. Okay, so that's done. Move that back out. Dot split int length equal to 2. Not operator. Oops, sorry, not here. And there. Okay, so when it's not equal to 2, it will do that, and if not, then let's take this payment method and let's split it again, and let's do that like that, and then we'll take the first. And this isn't really just a kind of like a C# guide. It's more of just, you know, we got to set up everything so we can kind of build out our dependencies. All right, so we got our product going in. Oops, product enum going in. Then we pass in our credit card information. And now let's build out our order manager. Okay, so our order manager, let's go here. So the order manager is going to do 3 things. It's going to check product stock before we try to make a payment. And then afterwards, if a payment is successful, we will ship the product. All right. So let's make a repository to actually grab the product stock. All right, so let's go here, add new class, and we'll just call it product stock repository. And we're not actually going to make a connection to some kind of database. I'm just going to actually just use a public static dictionary of product and I guess the stock number. And we'll just call this product stock database, just so we don't have to actually, you know, go through the process of it. And we're going to, let's terminate this for now. And let's just make a private static dictionary of product and int. And let's call our setup. And actually this is a private, sorry. And what we're going to do is we're just going to new up one of these objects. New dictionary, product, and int. Just so we have one kind of in memory so that as we use it, it actually reduces. We're going to say add, we're going to say product, and we're going to go, I guess we'll just go in order and just add 1 stock to everything. All right, that and that. So let's go down the list, add 1 mic, add 1 mouse, and add 1 speaker. And then we will just return product stock database. So this will be initializing it. And I'm just going to go here and do that. Okay, we have this. Now let's create some methods that we can use to interact with it. So one of the things we'll need to be able to do is we need to check to see if a product is in stock. So is in stock, and let's pass in a product. And I'm just going to say return product stock, and then we're going to pass in the key, will be the product. And we're going to say, is it greater than 0, basically, and that's to see if it's stock. And I guess I want to actually add this to emphasize something. Call get on database. Okay, just so you know that this is just a pseudocode, and that a real life code will probably call some kind of database. Public void reduce stock. So this will basically drop the when we ship something off, it will, you know, decrement the stock number. And same thing, let's copy this. Let's just copy both of these. Just something simple. Call update on database, and we're going to decrement. And we're going to add to stock. I don't know if this method is really going to be used, but it's kind of makes sense to, if you're going to reduce, you're going to increment. So this is our repository that we need. So let's go back and put it into our order manager. Let's go here. So I'm going to create a new product stock repository new. All right, and what we're going to do is we're going to use this to say if product stock.is in stock, and we're going to pass in the product. And we're going to say that it is not in stock. Then what we're going to do is we're going to throw a new exception. And remember, all the exceptions we expected to be caught and display a message. So we're going to say, let's say product toString currently not in stock. All right, so that is our stock checking, and let's now do our payment processing. Here, create a new class, payment processor, make it public. Okay, so we're going to make a public void, and we're going to say charge credit card. And what it needs is the credit card number and the credit card expiry date. All right, and I will add some logical checks here. So let's say we do some white space checking, and let's add a white space checking here, and we're going to say invalid credit card. And I'm just going to remove this just to kind of keep the message nice and clean. And here is going to be invalid expiry date. And at the end of it, if it all goes through successfully and some crazy business logic happens, let's say we call to credit card API. Okay, so that's simple as that. Now let's go back and add that to our order manager. Go back here. Now let's go var payment processor equals new payment processor. And let's just say the payment processor charges credit card, and we have the credit card number, and we have the expiry date. Okay, remove that. All right, next thing, shipping the product. It's gonna be a very simple service again. Go here, and we'll call this shipping processor. And feel free, if you don't really want to see this part of it, to just skip ahead, but it will be kind of important to see the progression of how the classes are built out and how a typical scenario, if you don't use DI, would be constructed. I'm going to say mail product, and I'm just going to pass in the product. So var product stock repository, not stuck, stock. And product stock repository, and I'm going to say product stock repository dot reduce the stock. Since we're shipping it off, we're going to reduce it. And Then we're going to do the same thing we did everything else. We're going to basically say we had some kind of fictitious API, and we're going to call to shipping API. All right. Now let's go back to order manager and add that in. Back here, our shipping processor. Okay, and then shipping processor dot chart or not mail product, and we're going to send the product off now. Okay, so now that we have everything together, let's actually go run the application. Let's go back here to program, and I'm going to do one more thing that I forgot is after it successfully submitted everything that we want to say that the product has been shipped off. So product.enum.toString, and we're going to say just has been shipped. Okay, so now let's run this. And our credit card number, I have one copied on my clipboard. It's going to just be a 16-digit number with a 4-digit expiry. So let's order ourselves a keyboard, and they want a payment information. So this is my payment information, and we're going to see our API calls get called. So get on the database, call to the API, credit card API for the payment. And then we're going to go back and ship it and update our database and call to API shipping. And then the keyboard has been shipped. So if we try to call for another keyboard, or we order another keyboard, it's going to say get on database, and then the keyboard currently is not in stock. Okay, so that is kind of what we have quickly built out here. So let's go back to the diagram and explain what we're going to do next. All right, so from the diagram, we've now created our order manager, our payment processor, shipping processor, and product stock repository. And our order manager news up a instance of payment, shipping processor, and product stock repository. So let's try to write a test for our order manager, and we'll see just how difficult it is to actually do so. So let's go here and create a new project. And I'm going to use XUnit. You can use whatever framework you want, because the most important thing you want to do is you'll eventually need to use Mock, MOQ, which is a framework to kind of create fake classes. Injection tests. All right, so create that. I'm going to create us a new unit test class, and we're just going to rename this to order manager test. Okay, rename this, and let's write a test for making sure that when there is no stock, it will throw an exception. Okay, so go back here. Let's add our dependency injection to a project reference. And I'm just not worrying too much about actually how test. I'm just leave it as test one. So let's go here and go order manager equals new order manager, resolve that. All right, and we're gonna say order dot submit, and we know that since it's a static dictionary, that it's going to have a stock of 1. So in order to produce that exception, we have to call submit twice. I'm going to copy my my fake credit card and fake expiry date here. So 1 second, let me just do that. So we know this first time is not going to throw the exception, and we want to make sure that the second time throws that exception. So we're going to have an assert and throw, let's just say throws any, and we're going to say throw any exception, and this is a action, so we're going to do that and just close that bracket off. Okay, so we know the second time of submitting it will do that, but in a real world scenario, we kind of don't want that to go to the database. You want to know that if product stock repository returns is in stock of false, we want to be able to kind of throw that exception, right, without having to go to the database to do that. So let it compile, and then we will run the test and then debug test. So we can kind of just step through. So I'll put it here too. Okay, so this will kind of introduce what we will need to do, which will be kind of to refactor our code. And once we refactor the code, we will write the test again. So we go here, and then kind of go to is in stock, and you can see it goes to the concrete implementation, and that means that it will call the database in one case. And over here as well, it will do the credit card call to the API. So this is a kind of a more integration-y test, which will actually call your different API providers. So we know that this first time now stock is 0. So the second time you come in, it's kind of say keyword currently not in stock, and our assertion will test for that. So we know we're trying to assert to throw an exception, right? So we will kind of be stuck in a scenario like this for all of our other tests if we start writing them, which basically introduces the scenario here where all of our objects are now somewhat coupled together, right? Our object manager needs to know about the product repository, and then it needs to then kind of know that that goes to the database. Same thing about the order manager. It needs to know that the payment processor does a credit card API call, and it's kind of like a daisy chaining of things where order manager just doesn't need to know that. Order manager just needs to ask the product stock repository, hey, is it in stock? Yes or no, right? Order manager cares about yes or no, not about it going to a database and all that stuff. Same thing with the payment processor. It just needs to know, did it fail or not fail? Did the money get sent or not sent? So to solve this is kind of where DI comes in, but one of the principles of DI is this dependency inversion principle, which states right here that high-level modules should not depend on low-level modules. Both should depend on abstractions. And also that abstraction should not depend on details. Details being classes should depend on abstractions. So from this, it tells us to create an abstraction. So that's very easy. We can go have an order manager, have an iOrder manager, which is an interface for that order manager. We can do the shipping processor, have an iShipping processor, and so on. But then how do we use those abstractions in our dependencies, right? So one of the ways of doing that is by using inversion of control, which kind of changes the way the flow of things work. So if you imagine in our original diagram here, the flow was kind of downstream, right? Your order manager created a new instance of product stock, which then created shipping processor and payment processor. What if that was kind of flipped around, and at the time that order manager was ready, it already had all of those instances available to it? And that is kind of what inversion of control is. And I'll kind of demonstrate this by using the constructor injection. Let's open up Visual Studio again, and let's just close everything. And let's create an abstraction first with dependency inversion principle. So let's first do that. So everything will need an abstraction. So public interface. And if you don't like it on top, that's up to you. It's just personal preference of mine to have it on the same file, since most of the time this will be what it's used for anyways. And then we will have that inherit. Perfect. So that's one done. Let's go to our payment processor. Same idea. All right, and then copy this method, have it here, have it then inherit this. Okay, moving on, product stock repository. And copy this. And it's a C# convention to, always have I in front of all your interfaces. So do that. So it's just syntax. It's not really required, but you should try to find the best practice if you can. Copy that. And do that. And then another quick way to do this is if you actually click on the class, control dot, generate extract interface, and then it will ask you what methods, and you can click OK to that. And it will put it in another file for you, but once I said, like to do it here, and I will delete this. Okay, so oops, go back here. So we have all of our interfaces set up for each one. So now let's start doing constructor injection. Okay, so usually I like to start from the lowest, most dependent object and then go up. So let's start with product stock repo. And in this case, product stock repo has no, let me minimize these methods, has no direct dependency. So let's go back here and let's go to shipping processor. So shipping processor, and because once you start doing this, things are going to start breaking. So we go here, and then we say here, and then we go expect an interface of this. And I'm going to remove that. There you go. So what we did here was we expected the constructor to pass in a implementation of iStock repository. And then what we're going to do is we're going to save that iStock repository and use it here. Okay, so if you had different methods, it would also use the same one. Get rid of that line. All right, so back up the chain. Let's go to payment processor. And once again, payment processor will not have any. If you obviously have your API, it will need to inject that in, but in our case, it is empty. And let's go to our order manager. So in our case, order manager needs a dependency, or sorry, shipping processor needs a dependency since we made it constructor based, but we will now pass it all up. And this is kind of the inversion of control. What we're happening now is we're kind of flipping it around, right? So let's start with this and do this. Okay, so we're doing one. If you're wondering how I'm doing that, I'm just pasting this. I press space and then I go to this, I press tab and then I press control dot, and it's going to create initialize field, and I click that, and then it will create me a private read only. It's a bit faster than having to type everything out. Same thing with this, right? Control and then enter here. So now we have all of our 3 dependencies. So let's put that there. Replace that. Take our shipping processor and place that. Okay, now we've replaced all of our dependencies with constructor dependency, or constructor injection, sorry. Our program, yes, should now be broken because this should now be expecting 3 overloads. Perfect. So I will show you how to fix that, and then I'll show you a better way to fix that. So right now we got a product stock repository. So let's go new product stock repository, right? Okay, then we got to get it in our payment processor. So new payment processor, all right? And then, oh man, now we need to have a shipping processor. All right, so new shipping processor. But now if you remember, shipping processor needs a new product stock. So we're gonna like do this maybe, and then maybe have one of these like product stock repository equals new, one of these, and then pass that in here and pass that over here, right? But you can imagine, like, as this kind of grows, as you add a new one, then you're gonna come back here and you gotta update that again. Or if any of these ones have a injection, like if you actually have a real payment processor API, then you got to add that here. So the solution to this is now the dependency injection container. So with all of the things together, dependency injection is now the implementation of actually how to do all of the prerequisites together in a nice kind of packaged way. So let's go ahead and start adding a dependency injection container. So we will be using the default one from Microsoft. So manage here, well, ASP.NET Core, or sorry, .NET Core. So Microsoft, and this is the one. Microsoft used to provide one called Unity, but I believe that is deprecated now. I'm gonna save that. And then there's also a bunch from other open source projects too, like AutoFact and Inject, Structure Map, and they're all pretty good. Just notice some slight syntax differences and some feature differences. So we're going to add a new class, and we're going to add a container builder. And what a container builder is essentially just a list of all of your abstractions to their implementations. And the reason why it's called a container is, or I guess because of Docker now, it's kind of a little bit more confusing, but it's just a name basically. And you can call it literally anything, a registry or whatever you want to call it, or whatever you want to refer to it, which will make it a little bit less confusing for you. But I like to call it container because that's what I was used to. And all the code here is just going to be specific implementation that is used for ASP.NET Core's dependency injection, and AutoFact and all the other ones will have like a getting started that you can look into, but they all kind of have the same idea where you kind of create an object, and that object in this case is going to be a service collection, which is going to be your container in this case. And then I'm going to do a build on the container. build service provider. And this object will be used from your program to kind of get your services, okay? Or get the I order manager in this case. And once you do that, now we gotta register. Let's do this by adding our order manager and then adding everything else. So we go container dot add singleton. So there's a couple of different ones you can add to ASP.NET dependency injection, but my case, just keep it extremely simple. We're going to do singletons, which will just be a one instance per class, okay? And how you register it is with generic. So you say what interface you want to have, which is I order manager, and then you say what the implementation class is, which is order manager. Okay, and then you just repeat the process for the other ones. So I'm just going to copy this, paste, 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 and I'm going to say I payment processor. Okay, and then do that for the implementation. Next, I'm going to say product stock. Okay, and then get its implementation. And lastly, the shipping, I shipping. And we'll do that. Okay, perfect. Now let's actually open the diagram from very beginning. So we open this and open this. Okay, so if you guys remember from when we first started this process, we basically had our console start up our order manager, and then that news up everything else. Now what we've done, which we haven't actually ran the console part, is that we've actually inverted everything so that we are ready to go when the console is ready to go. So the part here, what we've done is we've taken our, or I guess this part here is where we did the dependency inversion principle, where we took our order, we abstracted it all out, right? And then the next step we did is we got a container, which is our iService or our service collection. And then we registered all of these different dependencies to it. And what's going to happen now is when we start our console, or when we replace the code here to actually say, get me a iOrder processor, your container is going to actually give you an order processor, but not only give you an order processor, but give you all of its dependencies as well. And since it's through the constructor, the container will actually know how to resolve all those by itself. So back to the program, and let's actually set up everything now. So we have our container builder, and let's add it here. Public static read only, and we'll say I service provider, and we're going to call it our container. Okay, and that's going to be a new instance of container builder. And the reason why we have to do this kind of thing is because we, like, the console app doesn't have its own lifecycle. If you use like ASP.NET Core, it'll kind of have its own lifecycle and have its own kind of container. So you don't actually need to do all this step. You'll just use the ASP.NET lifecycle and hook into it. Okay, so we're going to replace this now. And what we're going to replace it with is container. Actually, let's add the using Microsoft extension dependency injection. All right, and here container get service, and then what service do we need to get? We need I order manager. And notice that I'm asking for the abstraction as well. Okay, I'm never asking for concrete implementations anymore. And that refers to our diagram here. Wrong diagram. This diagram here, where our console now is going to ask for an iOrder manager, or I guess this is, sorry, mistyped, iOrder manager here, and then it will kind of resolve all of its dependencies. So we can kind of see that working if we put a debugger here, and I'm going to kind of put a debugger here, and I will also put a debugger here. So we can kind of see the chaining of dependencies getting built. So let's start that. And then we'll kind of step through it and just watch the dependency tree get built. So I'm going to step into that, and we're going to see that shipping processor is the first one being hit because it will resolve from the bottom up. And then shipping processor needs product stock repository, and you're going to see that there is a implementation for it, right? So let's step out of that. And then now you're going to see order manager being resolved, and order manager is obviously going to have an implementation of all of these. And all of these, like I said, came from the container. All of them came from this container. So the container basically knew the dependency and passed it all there. Okay, so then step through that. And then at the end of it here, when you're getting your order manager is going to be able to perform the exact same functionality as it did before. So we go pass in 0, and then we're going to have to pass in a payment method. So I'm just going to copy that, paste that here. And same thing from earlier. And then if we do 0 again, and then we pass in the same payment method, keyboard currently out of stock. The last and final thing, let's go back to our unit test and actually write something that can be testable. So I'm going to go here, add a NuGet package for mock. All right. And mock has pretty good documentations if you guys are ever curious about learning more about it, but I'm going to show you really quickly how to set up everything. We're going to install the NuGet package. Okay, perfect. And I'm just going to quick rebuild to make sure all the dependencies are installed. Perfect. Let's uncomment this code here. And now we're going to create a mock of all of its dependencies and then pass it in. So we need a payment product stock repository. So product stock repository mock equals new mock, and then you pass in I product stock repository. Okay, and what mock will do is it will create a fake implementation for you. So you can now do things like this where you say product stock mock dot setup. Oops. Okay, and then it's a lambda here, so product, or I'm just going to use m for mock dot. Okay, and then anytime it asks for is in stock method, and it asks for it dot is any. Okay, so any product, we want it to return true. Well, in this case, we want to make sure it fails, so we'll return false. Okay, so this is how you read it. So we created our mock object. Our mock object we want to set up because we know that we want to test the is in stock to throw an exception, right? So we say that anytime is in stock is called, and this is a mock implementation here, then we say that it dot is any product. So we can actually say and specify specific products. So we can say if it's only a keyboard, then perform or return false, or if it's a mic, return false, and everything else will return true. But in our case, we just want to make sure that when we're out of stock, we want it to throw an exception, right? So I'm going to now pass this in here, and I'm going to say, give me the real object, okay? Because if not, it's just a mock of that object. So this will give you the object itself. So I payment processor and I shipping processor. So let's do the same thing. Payment processor mock equals new mock. I payment processor. Okay. And then copy this. And now let's just grab the last one, which is going to be I shipping processor. Grab that. Replace this. And then we have our shipping processor mock. So let's pass that in. And we don't really care about what they're going to do because we know, at least we're expecting it to not hit that. And there's ways with mock to verify that, you know, it's never actually gone there. But in our case, we don't really need to. So because we've now changed that, we can now delete this extra submit. And we can now be safe that if this was a automated test, that the automated test won't hit our database, won't hit our credit card API, and won't hit our shipping API. So let's put a debugger here. I'm going to actually step into it and put one here. Just remove all of these kind of annoying ones here. So let's do that. Let's run our test and see what happens. And if you want to actually kind of debug it, you can actually put a debugger inside of your mock and watch it do whatever you kind of did there with like any kind of special modifications. But since mine is really simple and it just returns false, I don't need to worry about that. So I expect it to now go here because I mocked up this method here, right? And it does. And then it throws this exception, and then my assert expects it to throw that exception. And that there is kind of like the power of dependency injection and how it can really shift your testing paradigm and have your code actually be automatable. So let's really just quickly go back to our diagrams and just take a look at what we've done. So at the very beginning, we had a console app. We built out the console app, newed up everything. We weren't able to test a very simple functionality of making sure that when there's no stock, throw an exception. And now we've created this kind of like confusing looking thing, but like I said, with dependency injection, the overhead is learning about the complexity, but once you learn it, it is extremely easy, because now all of this, you know that all this is just registry into a container, and then if you ever need anything, let the container deal with it, right? You don't need to worry about something that someone else has already written code about. All you need to know is I want this abstraction, and I don't need to know any of its dependencies. Thank you guys so much for watching this video. That's the end of the tutorial. If you learned something, make sure you give it a big thumbs up. It really helps with the growth of the channel. And if you have any feedback for me, just put it in the comments below and I'll definitely read it. And remember to subscribe to the channel to see any future videos. See you guys next time.